Elevation and Love. I'm Andre Romance, and I only got one promise to keep. I'm going to design this thing. I'll take it from the screens to the streets. Without further ado, let's get designing. So what we got is a special shout out to my boy Derek that reached out to me, who wanted to collab on a 1960s build for an Impala, and we're working with a 1 to 12 scale. So what I'm gonna do is I'm gonna start off from my chassis over here. If you all seen some of my previous videos, I designed this chassis here. What we are going to be doing with this chassis is using it for measurements. I'm not going to go into the CAD software and pull those measurements from the other parts. We're going to specifically design this for what his purpose is in his build. So I just wanted to show y'all real quick, what we are looking at here. This is a wireless setup where I built this thing with a wireless receiver and a transmitter. You know, this is a 1 to 10 scale RC car with a fully functional hydraulic setup on it. Front, back, left, right. Every individual wheel does its thing. Also, it is a 4-wheel drive setup. Um, But the flip side of what we're doing today is just for the purpose of dancing and hopping. So, with that being said, a lot of these components are not going to transfer over to this build, given that we don't need a drivetrain, we don't need functional axles. So, um, this build is going to be something different. We're going to start off by going into the CAD software that he sent out for us to kind of look at and see um, how we can get this thing to fit. Um, Really, when you're dealing with a certain scale, if you are doing your own designs, you can start off with whatever scale you want to start off with. You don't necessarily have to craft in a certain scale, like a 1 to 14 or a 1 to 16 scale or anything like that. If you're familiar with a certain scale, like I'm familiar with the 110 scale already, and I deal in inches. So when your brain already knows what the measurements are for those type of settings, it's okay to work in that scale and then um, scale down based on the percentages and make the holes a little bigger if you need to make them a little bigger. Or like if you're doing, say you're doing your heat inserts or whatever, your brass inserts. Like I know that's a 0.15 if I'm dealing with, my specs of, inches. But we're going to bring this up. So we'll start a new canvas here. Beautiful parts. We'll let them do its thing. So the first thing I'm gonna do, I got some stuff over here that need to be silent. Hey, version of this. Oh, see if I can get us all the way in the frame here. So can't actually see the browser, but that's okay. Or any of the components. Better. So the first thing I'm gonna do is bring in the file that he gave us to have a look at. So I'm gonna insert it as a mesh. This is the body that he sent us. So we're not going to do any manipulations of this body other than possibly scale the size that I want to work with. I'll try and see if we get the right scale here. So he has it in two parts. One thing is, all right. So when we're dealing in these forms, sometimes they'll come off as individual parts and pieces. We can mitigate those pieces by just making them invisible if we don't need them to be showing. There are certain parts we do want to be showing off because we want to line this thing up so that we can build our chassis based off of the dimensions of it. Okay, so with that being said, I'm just going to get rid of a lot of what we see here. Like I said, there's a lot of people on this thing, you know? And these are all the individual pieces that he created to bring this body to life. We gotta do a little bit of manipulating. Mm-hmm. Find out which parts I need to get rid of to get to the bottom side of this. Yeah. It'll look like a lot of these. And there are a lot. We are getting close. I feel it. I feel it. I feel it. I feel it. We're getting close. Let me see if that was the trunk that I had just came off with. It was an overbuild of the trunk. All right, we got that portion taken down. We just need to get that top side taken down. Left side, the right side there, that side there, and this side here. So I guess all the rest of them that don't have that exclamation mark next to them, they can just be taken off for now. All right. Now I want to get these bodies together. Okay. Mm. Let me see. And I do want to work in inches. I like to work in inches. Um, these two here. Let's see if I can merge them together. Bear with me. It's been a few months since I've been in the software, so my memory on how to navigate in here is off sometimes. Yeah, got the mount to 90. Mm, keep coming back down. So I should have opened this folder before I got started, so y'all wouldn't have to sit through this. But it's all right. It's part of the process. Sometimes you get a file, and then it won't be together as you need it to be, or as you'd like it to be. But all of the parts are where they need to be. And top, see if I can line this thing up. And it doesn't have to be perfect. You just gotta make it, make it fit for you. There are easier ways to do this. I'm not working on it. Maybe 7. That's close enough, right? Just keep in mind, all we trying to do is get a reference of how the chassis is going to fit together underneath this thing. That's all we want to do. I could rip more of this apart, like all that front end under there. We could rip all of that loose, but really ain't a need to. All we want to do is just build a base off of this. If you're watching it, looking at it from the bottom, we'll get exactly where the wheel well is inside of here. We can kind of get a measurement based off of line to line and what the direction is. Make a big rectangle and start cutting up from that rectangle. So we can start off by drawing a rectangle. So we come up here. We're going to be drawn from this bottom side here. We can start off with a square. I would start from the center line. Like if you're not familiar with, you know, how to mark all of this stuff up, you can map all of this out from the center line over here, which would be the smartest thing to do. And that's probably what I should have did in the beginning. I just didn't want to be struggling with it. Um, bottom. I didn't want to be struggling with it. But we could have gotten center line, right? We don't necessarily need a vertical center, horizontal center line as much as we just need a vertical, because we can work half of the body. It doesn't have to be a full workout of this body, okay? And so that might even be the way that I go with it. Let's do that. So instead of focusing on a full car, right, we can go ahead and cut this thing in half and work from half a vehicle standpoint, right? So from this right side here, we can get this line here and this wheel well portion lined up. The back side and the front side, I'll leave a little bit of space so that an attachment can be added on uh, for mounting brackets or whatever. I like to leave a little space so I don't go the full distance and width of the actual body. I like to build out. And we'll get into that later about why I would do that. Some people, they would like to have it to where it clicks in and sits firm on inside of the body, but it leaves no room for play, you know. So all right, so we got that. We're gonna go from the center. We're gonna create us a center line, right? So we'll go back over to where we was drawing at before. We'll edit that drawing. Never mind. Never mind, because it's not going to get us the center. But so let's just do this. Let's start a new drawing. Let's get rid of that drawing. And we'll just start us a whole new one, right? From the bottom, we'll start off with a center line. We'll select the center line in your little tab down line type on your side. I know you guys can't see mine, but I'll draw a center line here. This is going to be a good idea later on when we get ready to flip and do whatever we need to do. We'll be able to do that. So, meaning is of when I say I like to work in inches, that cuts down the awkward numbers and um, trying to get a specific size going with being able to fit this in. So see how like, well, actually you guys can't see the measurement too. Right now we're at like 14.785 on the measurement on the length. What I would like to do is leave space for the wheel well. So I'm going to leave that part cut open, right? Because this is kind of like the out portion of that. The length of this is coming in. So what I'll do is 14.7. Or even 15. So let's do 15 even, right? So we'll do a 15 even for the length, 15 inches. Hit the tab key to go over to the upright dimensions, and we'll take that down to 2 inches. So it'll be a total of 4 inches width, right? And we'll plug that in. Now we want to find our center areas for our wheelbase. And this is important because if you don't find it early on, later on you'll be trying to figure out how to make it fit, right? You'll be struggling with the wheel well lines not lining up for you. It doesn't have to be perfect. It just has to be uh, somewhat of a reference point to what you have here. Okay. So what we'll do is we'll finish this out. I'm going to extrude this. This gives me something to draw on to. I'll make this about a 0.2. Which gives it a little thickness. Gives us a little pad to work off of, right? As you can see, it's not going to stay this way. This is just a foundation to build from. It's just how I do it. This is how I can see what I'm working on, right? If I want to take these, let's move all of these down. And I can move them closer to what I'm working on. Yep. The wheel wells usually are open double this amount. Usually it'll be like maybe an inch and a half of play for the wheels. With the hydraulics, the axle moves around a little bit, and so you just have to leave space open for those wheels to move around. And then if especially if you get fancy with it, you want to get fancy with it and have like link rods and stuff like that. You gotta have room for that stuff to, move around how it wants to move. These are gonna end up being chassis bars, just I-beam style frame rails, and you're gonna take it from the rest of the way. Now I was saying, so from the side, now from the side, I can pretty much map out where I want that center area to be. And it doesn't have to be perfect. You just have to kind of have a good eye for exactly where you want to put these things at, right? And then drop your center lines and make those happen. Another way you can do it too is to just draw your circles out. You don't have to necessarily make holes or anything like that. You can simply draw out a circle, right, for that right height. If you already know what size wheels that you're gonna go with, those could be implemented when you're pulling it out, how big your wheels are gonna be. I don't know off the top what the size of my wheels were. Um, but we can go 0.16 to 16 to start off with. You know, we can go 1.6. Key it in there, and then the same difference up here. You can find that healthy medium of just eyeballing where you think that wheel would lay. And then this area here would be kind of like between ride height and what you would see the actual um, lifted version of the car where these wheels would lay. Now this would be the rim. Okay, let me specify. This would be the rim, not the whole total um, wheel with the tire attached to it. This is from the standpoint of just a wheel, where you will see that wheel well at. We want that for the purpose of being able to eyeball where those axles are going to lay. And then once you start building the structure of the suspension area, it just gives you an understanding of how much play you'll have. Like say I want my I want to make a bend on this thing to where the wheel well follows up all the way here. It'll kind of help you keep a reference point as far as how deep to make that bend. And then also you can move these circles around later on to catch that viewpoint. So we're gonna do, now that we have these wheels here, um, is build off of that frame portion that we have. We also want to extrude these out so we can get a specific location for how these wheels are going to be placed and cased in. Okay. Um, some things to point out though, a lot of what I got rid of, if you're not really familiar with the chassis and how the inside parts line up with the chassis, you might want to leave that stuff there, like the interior. And when you're designing, you will pretty much just move it, move your parts based off of those areas. So these two, I want to extrude out. Right? I'm going to extrude them out but keeping them individual parts. This will give us just a mock-up of what these are going to look like inside of this wheel well area. So 1.1 gives us a good crease down inside of here. Also, the thickness of the wheel is not going to be 1.1. You're probably going to end up with about 0.6 or 7, or maybe even a 0.8 on the thickness, depending on what type of style you want your wheels to be. But that's the beauty of being able to design your own wheels too. So based off of my wheels, I'm at a 0.8, right? So with that being said, I can line this up at a 0.8, 0.8. Get rid of that joint. We're gonna make a new part. Then we'll move that up. We're going to do the same thing for the other side too. We can't see sketch anymore, so we gotta go back into the sketch file, make it able to so that we can see it again. Do the same highlight of those shapes. 0.8. There's not on joint. New. The OK button. Now these two portions here is just tires, or just a wheelbase. Now if you want to work with the tire, you can make these big enough to be the size of a tire if you like. I'm not gonna go through that depth. I just want a reference of the tire or the rim itself, because that is the portion that's actually going to um, link in with the axle, right? That's what we want to focus to. You got to focus on how that wheel portion is going to attach to the axle. So we're just getting a rough estimate of a couple of things to pay attention to in the beginning, and knock out some things like really early on. So later on we're not worried about how it's going to come together. So with that being said, we'll take those two bodies that we just created. And I'm going to move the out to where it's going to kind of line up in reference to where we want to see this fit inside of the wheel well. The thickness the that the body would be for me is about a 0.2, anywhere between uh, a 0.2 and a 0.15, just to kind of give it that, rigid sturdiness. But that goes back to whatever your material is going to be made out of, whatever material you're making this out of. That's going to play a big part in what you do. Okay? So I want this to set out about there, and I'm just eyeballing this. If we're at 0.03 and I see this is that's going to give us a little gap in between that 0.2 that I was talking about. This gives us that 0.3, right? So if we're looking at it on both sides, you can see how those wheels lay in there nicely. That's all we want to do. Okay, but we don't want to complicate it. So simpler you do it, the simpler you make it in the beginning, the better off you'll be. This would be a standard ride height, you know. So now that we got that, uh, it shows you how much you can work the play. Now on these frames, because I do use the brass inserts for all the screw holes, I like this thing to be at a 0.5 thickness. This just gives you enough meat to put your inserts inside and still have the sturdiness of the part. I'll try going as thin as 0.2, um, which leaves no room for inserts. So you would just be drilling right into the plastic with the M3 screws or M2 screws or whatever. And the thing with that is the more you take those screws out, the more those holes strip. And once the hole gets stripped, the screw isn't going to hold anymore unless heat the part up and, reapply filament inside those holes, retap them or whatever. But it's a lot more of a headache to deal with. So especially if you're dealing with like a hopper, something that's going to have a lot of torque pounds on top of it, it's best to go thicker. So that will be the next step of what we're going to do here is to get this thing thickened out. Okay, so in order to do that, I'm going to take it from the front or the back. It don't matter. You just have to be able to see that area that you're working on. So we can get rid of that side view of that sketch. We're going to take a sketch from this portion here now, and or actually, we don't necessarily need to do that, but we could, right? We overall we want to still have this base here. This will be our building plate base, pretty much. We'll take our measurements from here, and we can extrude out. Better yet, that's what we'll do. There's so many ways to do this, guys, and I think like when I'm designing, that's the thing that I run into the most problems with, is because there are so many ways that you can map this out and design this that you don't necessarily have to start out with a flat plate. It just gives you that length and that distance of where you think things should be, right? So, but what's next to think about is how do we want to um, mount those servos, right? How do you want the suspension? How do you want the servos to be mounted? What is the what is the measurement of those um, suspension parts? Like for instance, so the suspension that I showed you all from the top view over here, that suspension, those springs are, I think, 54 millimeters long. Um, it's your preference of how um, tall you want your suspension to be for the play of the actual servo. The servo arms kind of give you um, a tolerance based on how long your suspension is. So if you look at this here, this is I want to say is 74 millimeter. Actually, I can use my calipers. Sometimes you'll have a suspension that's going to be a little too tall for your application, right? So this is at 80 millimeters, right? This one, 80 millimeters, right? That's one with the springs. Also, you have to think about the thickness of the springs, right? And how it's going to fit next on the side of the axle. This is one without the spring, which is kind of one of my favorites for rear suspension. These are pretty cool. But all of these have hydraulic fluid applications. This one is set at 78 millimeters, right? But the ones that I have in that car over there are like 54 or something like that, which is perfect size for dealing with a 1 to 16 scale. It's short enough that you can get those servo arms flat when it's at lower level, and when you're going for full ride height, you'll have it up there at where the servo horns are facing downward, where it kind of locks in a little bit, and that just gives you a little sturdiness. Um, but we don't have to worry too much about that because this is not going to be a driving car. He wants this car to specifically be for the hopping and dancing. So that gives us a lot of play, a lot of wiggle room to do what we want to do with the servos and how those are going to be mounted. So usually how I like to mount the servos is in the front of the chassis, in front of the axles rather than in between the center of the body. And I do that just um, for the height of the suspension and also for the weight. So you need a little weight on the outsides of the vehicle in order to give it that bounce, like when the body is coming down from that bounce, right? You need like a little weight to push down on the suspension and make it gives it that realistic bounce of real suspension when the vehicle lands. So that's what we want to focus on here. I'm going to draw out from the center area where I think those points are going to be at, and then we'll take it from there. So the center chassis part is not going to move. This could actually be higher and tucked inside of the body a little more. Like I said, it just depends on the length of your interior and all that type of stuff you have if you have the interior set. But we are going to worry about that. We're going to go based off of the body height at the bottom. The bottom edge is kind of like what we're going to be dealing with. So because we lined this up pretty much off the bottom line, we know that we have this uh, the length of this, which is a 0.2, right? So we know we can take this thing up just right at the edge of this, and it'll be a 0.2 lower than where this will actually sit when it's inside the body, right? And this is just so that we can see what we're designing as we design it. We can follow this edge here, and then we can curve it around, which would give us plenty of room for this to drop in and mount how it's gonna mount. Now I do like to leave a little space inside of this wheel well area. That's very important when you get ready to put this in. You're gonna leave a little space here to where you can actually get your screws on the top side. If you're not dealing with inserts, you can still get your screws down in there on the top side without it bumping up against the top of the body. In most cases, you'll have more space in the front side than you do in the back, unless you have like a two-door like this. If you're dealing with like a sedan or any type of vehicle that trims down back here in the back, like for instance the 64 has a really low trunk space in the back. The Monte Carlo is the same way, has a pretty low trunk space. Those type of vehicles, you kind of got to think about it ahead of time for how you're going to mount those servos, because you will run into some issues later on when you do your printouts and you start to put your hardware together. You see that space isn't there that you thought was there. And it's kind of mind-boggling to get to that point, right? So, well, with that being said, but we're gonna draw off of this, like I said, the center of this wheel. It's kind of where we're gonna space this wheel out. I'm gonna draw a circle based around this, and then we'll take it from there. So from there, we'll get us a circle based off of the center of this circle, right? And it'll latch to that circle if you're center point, and that's what you want all the time. You want it to be center point. What we're gonna do is pull all the way out until we get to the edge of that mount there, right? That's where I'm gonna draw my circle from. This kind of gives me a radius of where this wheel well is going to be. Okay. Now it's not going to end up being round like this. This just gives me a reference of what's happening here. And then also pay attention to what that measurement was so you don't lose it. Okay. What you do in the front in most cases is what you're going to do in the back. But you have to maintain that let me see. It's good to maintain that consistency. So that was a 3.8 that we did right there. So we'll do the same thing back here. 15 center, 3.8. 3.8 is going to push us to where we're going to end up going a little backwards. But we do want that. We want this to sit nicely. So with that being said, this wheel, I believe, is a little too far forward because we are so far away from the outskirt here, and we're kind of into the door area here, or back seat area here. We don't want to be that far up into it, this as far as the inside, that we're designing. But outside it should be fine. If y'all following me, if y'all let me know if y'all don't follow me, what I'm trying to do here, because sometimes it can be a little confusing as to what I'm doing. From this circle here, we're going to figure out what the distance is between this shape here, right? These two sides here. Now with the front, we don't have to bring the front down like I did in previous builds, because it's not going to be driving. We don't have to worry about this vehicle crashing. So our chassis could pretty much stay up top and have our servo mount to do that downward motion and stuff like that. We don't technically have to work any of that ourselves. Okay. So we're not going to do that. Another thing too, we can always start from center and frame it out that way. You know, that 3.8 by 3.8 will give us a crazy 3.8 by 3.8, 3.8, right? Another one there. What we could do is we can keep that portion there, round it there, and then taper this part off to the top side. And there's nothing wrong with having this roundness here, if that's how you want to do your design. Okay, keep that in mind. We're drawing these squares from the center, from the center of the circle. Excuse me. 3.8 to 3.8, and then we'll go in. Let's get rid of these bodies so y'all can see what I'm doing here. Right, front and backs, right? Now, this is what I'm talking about with styling, how you want your chassis to be. You could take certain lines away and give you a nice crispy, you know, design here for your chassis. But a lot of these we don't need because we just want this line here, that line there, these lines here. The rest of these, we'll get rid of them, right? So here we are at the roundness of that, the roundness of this. Now, like I said, this don't have to be round. It can be squared off. It just depends on what your style is when you're doing your design. Whatever you want your style to look like, however you want to do this, it's up to you totally. This front side, we were saying, is going to be more room here. So we're going to design this to push off to the top side. This one here is going to be a little lower. So we're going to push off to the bottom side instead of the top side. So I'll give you an example. So we'll highlight these two here, right? We're going to do offset of this here. And what I said before, I want this thickness to be 0.4. With it being a 0.4, it's going to take it inward 0.4, right? So once we got that portion set, we can come here, or oh, sorry about that. Let's undo. This is going to be negative, right? Because we want it to go to the outside. Negative 0.4 to the outside. When we put our body back, it should line up to where we can actually see it inside that body mount. I mean, we might have We may run into some issues with this, so we might have to bring them down more. What you got going on, my boy? All right, so we're gonna bring this portion down, and then the other one we're gonna bring it. We're gonna design this down as well. Okay, so offset. We'll bring this down 0.4. It's crazy that it's 0.4. This side is negative and that side is positive. Right here, this side is perfect. I see the blue line here. It gives us some nice little space in between there. Also, when we get ready to extrude these, you're gonna see it a little better than what you're seeing right now. When we'll go back to our lines, we'll close these up. All right, close them right on up. Close this side up too. This portion here is sticking out pretty far from where the front bumper area is, so we're gonna make sure that we tuck this in, we tuck it back. And how we can do that too is we can offset this. We can offset that front mount there. But it was a 0.3 that we had spaced out before. It's in the house. Bug got in the house. What type of bug? Let's go 0.7. We can do a 0.7. We'll get rid of these. Front area up, this area down. I think we got go to mama. Go to mama. Go to mama. You need your diaper change, my boy. Go. Something. You did something, my boy. Go and get that handle. Go ahead, man. Go handle it. Go get it taken care of. All right. So we're here with it. We gotta go and tie this into that right there, right? Um to push these back here. Could have done this all in one go round, but the idea is to create that wheel well, right? Create that wheel well, have it then cut open from where the wheel well is to where the chassis area is, and also have this lip here. See the small lip? This is going to give us the power to play around with how these two parts meet together. If I extend this all the way to the bottom, then I won't be able to play around with the bottom surface of these two fender parts. Okay, that's why we left that gap there. So it'll make sense later on. This is just kind of how I do some of my building. I leave a little space so that I can actually manipulate it later on. If I don't leave space for it, then I won't be able to manipulate it. But what we want to do is extrude, right? And just click on that surface where we were at before, and it's going to extend it out to where that surface meets. See? Now, it's all right if we join these together or if we make them individual parts. It doesn't matter because right now we're at a place where we can always cut them down the middle if you don't want to keep up with them or if you just want them attached to one portion. So, I mean, for now, I'll go ahead and join them all together so they're just linked together. Okay, so those two fenders, right? Wheel well area is a little thicker than what I would do for the actual framework, right? So these are the fender wheel well areas, right? Which they don't have to be as thick as the frame, right? I want you to understand this. The process of designing is not always for the aesthetics, but also you have to think about how this is going to uh, function and how the durability of it will be uh, once you start making it, you know, making other parts pull against other parts. Like structurally, it has to function at a certain strength. Now we want to extrude these into this base plate by that point four that we was talking about. That point four is the thickness of the actual frame. This gives us enough space to put our holes at the top for where our servos and things are going to be mounted to. Okay, so this extends us into this base plate now. So at this point, we can cut from the surface here. We can cut from this surface um, straight down through this base plate here. That would give us, that would divide this whole thing um, to where you will see the frame and not only the frame portion, that bottom rail of where the frame is going to be, but also you're going to get the portion where the wheel well meets the frame. That whole portion comes together nicely. So we'll splice that. All I have to do is select one of these sides. It don't matter which side you select it. You're gonna split body and choose, and it should already be selected what's gonna be split. As soon as you split it, now you have these two pieces. You have this rectangular piece and you have this frame piece. So if we scroll down, you can get rid of that piece and you can see this is the chassis frame area here. And this is the rest of that. Now this portion here is that small straightforward area that it's not necessarily needed right there, but it's going to have a weird cut off when we get ready to chop it. Right? We'll save that for last though, but this still ties us into being able to figure out where that axle is gonna be and how far off we want these, um, how far off we want the axle to be from the wheel wells. Okay. All right. So based off the top half too, we can actually splice these two and have just that rail there, but also have the wheel well areas. We can also have it to where we can thin out these wheel well areas. If you so choose to want those wheel well areas, you can have them. Um, what I like to do is trim them all out so that I don't have to worry about them later on. This just gives me a frame area that I can work with. Also, remember that thickness of this portion here, it was only set to a 0.2. We can add some thickness here by selecting that inner area and using this press pull, I mean, and we can press pull it. It already has it preset to 2. We could take it up to 4, and that would give us that height to match the rest of the frame here. So we can go that route. Okay. We have right now we have a good standing point where this comes into play. With the outside, we're good. We have a good standpoint of where that wheel is going to set versus where the frame is sitting. This should be a 0.3 distance, right? Which is a okay amount of space between the frame and the wheels. The beauty of designing the chassis like this is that you can always create different linkages between the frames for different widths. So what I mean by that is the bar. Let's go back to the front. The bar that is going to attach the front side of this chassis is going to be a separate part from the actual chassis. You're going to be able to screw that part into this portion of the chassis, and it's going to overhang on this part here. That's why we needed to have that space in the top. Now, if we get to the point where after we've designed it, we don't have that space in the top for this to fit flush, then we'll make some cutbacks or whatever we need to make in order to make it happen. But we don't technically need to focus there in the beginning, right? The roundness that we have here might need to be adjusted in the overall so we can get a flat surface to mount that thing onto, or we're going to push this whole section backwards. Same difference for this as well. These are things to think about before you design totally. Like I was saying, this wheel is going to have to be pushed back a little bit, but we'll still have that flatness to where we can mount the areas together. But from there, from this point, we're thinking about where our servos are going to be in the distance between the servos, how they're going to be positioned. There's a lot of ways that we can do the mounting for the servos. Like I said, if you're dealing with a car that's not going to have interior, you can have the servos in the front, or you can have them inside the cab area. Um, just depending on what type of design you're trying to go with. Let's see. We are an hour in. But next thing that I'm going to focus on, and that we should get out the way probably, is the axle. Some people, they would like for the axle to be encased in plastic, because it has like a more realistic look. If you're going to print out how how an axle looks, like the casing of an axle, it looks nice. You can put like little rivets and things like that into a printout for a 3D model, and it just makes the axle look more thought out, more realistic. But also, you can go with just a shaft. You know, if you go the shaft route, then the only thing you're thinking about that needs to be thought out is how the hinging is going to fall together for the linkages, right? How the swing arms are going to go together. I have a swing arm here. These here, right? these swing arms here can be designed all different type of ways. They can be long, they can be short, you know, you can do so much with these, but these have to line up a certain type of way according to how tall your suspension is going to be. Because we don't have differentials to worry about, we can get those swing arms to be so much closer together, and that would give us um, a crazy clearance for height as far as dropping and lifting this vehicle. So we go back to the top side. If we come at it from this middle center point to here, we probably want to push about an inch space in between, and then have our linkages attaching from that inch mark and extending all the way out. What this does is it gives us a huge play for spring action when we want to, you know, bottom this thing out, and also when we take it all the way to the top side. Yep. Hmm? Yeah, coming down. If you do one, I'm gonna get you some oranges. Go drink some oranges. You gotta keep resting. Go get some water. Okay? Get hydrated. Right. All right. So what I'm gonna focus on next is we're gonna go back to the center of the wheels, right? From the center of the wheels, we're gonna define uh, what we want our wheels to do. So what I'm thinking is based off of the wheels, right? We're going to make our pivotal points. The distance in these wheels, I think we'll make our link. We got knuckles, right? Because this car is not going to be turning or anything like that, we can comfortably put the knuckles in place at, let's say, an inch, right? A 1.0. So based off of the center of this, we can select this one to do our drawing off of. So we'll make this invisible for now. And also let's name these so they don't lose us later. So this will be frame, right? Let's zoom out, see what that was. Okay. That's rear wheel, right? Front wheel. I guess this could just be center. Center floor. Okay. And we'll come back to this portion. This portion, it'll just give us a reference of um how we're gonna chop this up and make it part of the floor if we want to make it part of the floor, you know. It don't necessarily have to have any extreme functionality to it. It's just there for if we want to use it, right? This would be front fender well. And I might have spelled it wrong. Don't judge me though, okay? I'm a designer. Rear fender well. Yeah, I might have spelled that wrong, but I'm not gonna look it up either. But don't y'all be judging me neither, okay? All right, get rid of the center floor. We're gonna get rid of the frame right now. All right, so let's just have the wheels up. Technically, we only need one wheel up because we can duplicate this and send it to the rear. Um, the rear is possibly gonna have a different axle base to it anyway. Um, it's gonna have a straight axle for the rear, and then we'll have the knuckles in the front. So let's go from there. I'm gonna draw off of this, base off of this. We're gonna get us a picture going. We're gonna click on that surface to draw right onto that surface. Right. We are going to get a rectangle, right? Drawing from the center point. We're gonna move around until you get that center blue circle or whatever color circle you have. That's gonna give you the center point of that circle or whatever that object is that you're drawing on top of. And then when we pull out, this is going to give us the dimensions of what we're dealing with, right? So this vertical is going to be at a 1, right? So it's going to be 1. Our width probably a 0.5, depending on how thick we want. Or actually, it can be a 0.4. But let's start off with a 0.5. Let's do a 0.5. Okay. We'll keep it simple. I'm not going to overthink it. Sometimes you can overthink this stuff, and then later on, you're going to end up changing it anyway. But we'll start off with that. This will give us the point averaging of this swiveling mechanism. We can also put a circle in here for the hole where the wheel is going to attach to. There are so many things that's going to go into play here for how to mount the wheel, because I mean you can use a screw to mount the wheel. You can have a stud that comes out through this like a little shaft, and that prints directly into it, to where all you have to do is snap the wheels on. That wouldn't be a very sturdy design, but it is something that you can consider, right? I'm gonna go over here. I'm gonna hit that center again. 0.15 is the average hole size of our shaft that we have. I'll do a double check on that though. Let me double check. If I was mistaken, it would be a 0.2. Now, I got a shaft. I got another shaft down in a bucket somewhere, but it would be the size of the shaft would be a 5 millimeter, right? So what we're gonna do is we're gonna go 0.2. Okay? Now that might be a tight fit for some, but we're gonna keep it at a 0.2, right? 0.2. This part is not going to get extruded. Only the outer portion of that will get extruded. Also, another thing to play around with too is if you do want to have a screw that screws into this, you can have an impressed bolt on this side as well, to help with that grabbing of that bolt, right? When you're screwing your screw down inside of the, that's another thing that you can do, okay? Which is awesome if you want to go that route. Because like I say, this is because we're not driving that 12 millimeter hex that would normally be on the inside for locking the wheels in, don't have to be on the outside anymore, right? That could be implemented here, you know, because we're not working with any front wheel drive or anything like that. So it makes it a lot easier for you to keep up with something like a 12-inch hex. But with that being said, because we'll be using nuts and screws, preferably an M5 screw for the front. And let me check. Let me check. All right, I have here a case of M screws ranging from M2 to M5, right? And you can get these kits on Amazon. There's a lot of places you can get these kits. What they do have is different sets of screws with the nuts so that you can, get your design on different thicknesses of the material. And from time to time, what I like to do is measure out based off of the size of these screws. I got the wrong one. Hold on. All right. So based off of M5 nut, it's good to have these on deck, on hand where you can, bring your calipers out and measure to press these things in to a space, right? So this is a 0.3 nut, a little over a 0.3, right? 0.306, which we can comfortably take up to a 0.31 or a 0.32 to give you some wiggle room if you're not confident. But a 0.32, right? Got a little play in it. 0.32 from flat side to flat side. We'll go in and create us a polygon, right? We'll choose from the side. There's two ones that you can choose from, that will give you different measurements, right? The circumscribed polygon is going to take that measurement from the flat side of the polygon, and then your inscribed is going to take that measurement from the tips of the what you got from the tips of the polygon. Okay, we want the circumscribed. Different size. The front wheel threads are different from the rear wheel threads. So you have to buy pegs specifically for the rear, because the rear wheel whole shaft is thicker than the front wheel shaft. This is pre-recorded. So here we are, that 0.3 from what I was saying, that 0.32 is going to get cut in half, right? And it's going to get cut in half because it's measuring from the center point to just one side. you have to keep that in mind when you're doing this, or you're going to, you know, gonna miss your mark. So point 14, point four, what is it? Point 14.4. Let me do the math on it real quick. Let me go look at the math. And how I get around to that is I'll do a point 32 because that's what we wanted. And I'll divide that by 2. I get a point 16. So I was off. See? But it's never bad. It's never a bad thing to pull your calculator up. Ain't nothing wrong with pulling the calculator up as long as you get that measurement together, right? So we are here with it. We're going to go a point 16, right? Nope, over here. Let's click on that real quick. Point 16 locks us in right there, right? So the center area will have a hole in it. This would have a depth to it, but it won't be fully extruded, as this part here will be fully extruded. So the thickness of this part will be contingent upon how how deep you want the inside of that nut to sit, outside of how thick you want that structure for the wheel hole to be. Now, as far as the thickness of that hole that we want to go with, we most definitely want to do at least a 0.4 for that. Because remember, we're going to be, this thing is going to be jumping, right? It's going to be jumping, it's going to be doing all kinds of stuff, right? So we're going to keep this consistent with the thickness of the frame. So we're going to bring this, we finished that drawing out. The first thing we're going to do is get the proper depth of that part. So this nut area here, this polygon is going to be extruded by that 0.4, right? We are going to come over here, extrude that polygon 0.4. Now, when we do this, we are not going to join it. We do not want this to be joined to the wheel. We are going to extend, right? So that's a new. Now we have to get rid of this wheel, because what we're going to do next is join our next extrude to this polygon. But if we choose join, it's going to join that part plus the wheel. We don't want to deal with that or have to separate it later. So we're going to, take it away for now. We're going to bring that sketch back. The last sketch that we just got through working with. We're going to take this outer structure here. It's going to come out further than this portion here for the nut. You can measure the thickness of the nut, and that'll kind of give you how much extra to extrude this out. Like a 0.13. So if you want it to be encased a little bit, you can put a 0.14 on there, so it can have a really nice bite. But it just depends on how thick your nut is. So we'll extrude out. We did a 0.4 plus that 0.14, which would be 0.54, right? So we'll extrude that out 0.54. 0.54 gives us a little bit of inward, activity there, and we leave it on joint down on the operation. So it locks this one thing in as one part. So that's the first thing. Now, we like this thickness to be here for the structure of, or the strength of this part, because we are going to be sending it through a lot of hops and a lot of torque, weight. We need that consistency to be there. Also, we're going to be drilling some holes down through here as well. For that portion, we might want to extend these up here to give, to give us a little bit of leeway with that, with those angles, what we were talking about, how we want to bring the floor in, right? And how this is going to come into play with creating that hinge, right? We are going to have this hinge thing going on. So whatever this is right here, the length of this, what we said, an inch play, we might, you might just have to play around with it to see how much space you want to deal with this. These could extend out more, like I was saying. You can come at a 45-degree angle and extend these up so they have a little more play when you're dealing with the swing arms, I mean. We're gonna do the same thing to the center portion with the size of this, right? So this was a 0.54 by 1, right? 0.54 by 1. We become center area. We'll lock that in from the bottom of the flat plate, right? We could come in and draw that in. But also we want to be right here on this playing field right here, right? And we could do that by offsetting, right? So we can go here, right? We can create a structure. We can offset the plane. Instead of clicking on one of these walls, we can click this wall here. And we can click the OK button, right? Now, when we get ready to draw, we can draw from that plane as well. We can draw straight off of that plane. And it's going to give us that center hole, but from that plane of drawing at the same height of the center portion here. So what we're going to do is we're going to come in here, grab our square. Straight from that center line, we're going to patch in a 1 with the tab button to go down to the bottom portion and 0.54. It's going to give us that dimension. We're going to finish the design. We're going to take that right there. You see how it got us right lined in with that square there. We're going to take that other body part away. We know where it's at. The center floor. And we're going to extrude this, to this length. Now these lengths, they have to match, right? Because this is where the swing arms are going to kind of sandwich. We came in at a 0.5 on these. So we're going to go ahead and extrude, right? So cancel. And the extrude will go any direction you select from. So if you select from this side, then the extrude will happen on this side. I was wrong about that. It still gave us the wrong way. All right, 0.5. It's going to be negative 0.5 for this one because we was on the opposite side of what we drew, right? Now, on the floor right here, sleeping. He's tired. All right. I thought Drew was in my room. So now, technically, I could fabricate what I want to fabricate off of these swing arms, right? I would just have to get me a nice area where I want these to communicate with each other. As far as the linkage, we're going to move these. We could move the wheels to match up with this height. And, draw these in from a flat plane, which wouldn't be a bad idea. All we'd have to do is take these like this, select this body part, move, um, move the surface, click the bottom. Well, let me see. This is where I forget exactly what I'm doing sometimes. Sometimes I don't always have the right logic of how to do stuff. A point to point. So if I'm going up from a point to point, point 4, it already have a lock in where we want to take this. All right, so is that a point 4, right? We can go point 4 for the height of the of this here. I did not move the sketch, which kind of throws us off too, because we could have moved the sketch and then would have moved the block. But we didn't do it that way. So later on, that's something that you'll have to worry about. I'm not going to worry too much about it because I already have my structure in place for where I want everything to be. And any type of new thing I'm going to do is going to be from a new, it's going to be from a new drawing. So I'm not worried too much about that. But as far as the linkage, right? Now we're getting back to the linkage. Between that part and this part here, we can do a quick measurement to see exactly how far off that is. An inch 0.2, right? So inch 0.2, it's a little shy of what would be ideal on a 0.10 scale. But remember, we're dealing with a 0.12, which is not too far off. But if we go back to the reference of the lowrider that we have, on file here, we got to go based off of how this thing fits together. So with that being said, this linkage is going to have to fit the swing arm, and also it's going to have to fit that spring in here during the collapse and movement of this part. So we have to consider that. Where this bottom link is going to have that hole for the spring to mount to it, but also this top portion, wherever that wheel well area is going to have an attachment area based off of this here. So this is not going to be the whole total height of this bracket here. We still have to add a top portion where that spring is going to mount. Preferably off of the arm is what we're thinking about doing here. We don't have to put it on the top arm because the top of that spring is going to have that servo mounted to it. That servo horn is going to be mounted to the top portion. So we have to just keep in mind how this is going to play together, because we have to have that space in between where that servo arm swings down to push that spring down. You want to get him? He's sleeping. I don't know what happened. He was talking for a minute, then just knocked out. Yeah. We got our frame here. Let's see how our frame is overlapping our part here. This is something to pay attention to as well. That gives us the idea that we have to move this frame inward, right? But what we can do is offset this whole part here, offset it by 0.4. By offsetting this by 0.4, we give ourselves some space for this thing to ride once it kicks down and tucks in into the framework. We'll be able to see this thing sit lower inside of the frame area. And also we have to worry about this bumping the frame rail as well. Okay, so we look at this part in our designing. It gives us the ability to see exactly where we need these things to go. So we'll close that out. We'll bring this in. We're going to move that whole thing 0.4. Right, 0.4 just seems to be like the magic number with dealing with this stuff. Right, 0.4 brings us into the inside of this, the alignment of this wheel here. Actually, let's not do it just yet. Let's pull back on that for now. That portion I forgot is going to be cut. This portion here is going to be cut. We're actually going to extrude this back till it goes flat here. So let's hold that off for last. Okay, we're still holding this space here for the integrity of the mounting portion, just so that we don't overdo anything and we still maintain that the space that we need to. Okay, it just makes it better so you can see. But we're going to cut this off. Okay, it's not going to be there. We actually can cut it off now by holding this part here and just pulling straight down. That will give us the cleanest cut. Okay, but we're not going to do it right now. We're going to hold off and wait. So like what I was saying before, the movement of these two pieces here are going to do something crazy. Right now we're creating all of this on one frame. Now you or not one frame, but one body, right? If you'd like to, you could use different components to start crafting these and having the components together. I'm not going to put so much emphasis on it right now, because I know that later, once we get all of the design together, that we can create a component based off of these body parts later. And that would be that'd be the takeaway from it. So this right here, front knuckle. Okay. And then we're gonna get these distances together because I want these swing arms to have a distance of 1 inch center hole to center hole. That would give us a good base for the swingage. Let me see. So it can be 1 inch or it can be anywhere above, you know. This will give us enough space for that play to happen with the actuation. And we just play around with the dimensions to kind of get that swing arm feel together. So we'll get rid of the frame for a second again. We know that the length of these, the height of these is 1 inch thick. So we'll mount our holes. We'll draw in some arm. We'll start with the bottom arm, which will have a hole going directly through that bottom portion there. Let's zoom in. Let's get our sketch on. We'll draw straight onto these areas here. So we'll have for M3 screws, so that we have some sort of play. We'll do a 0.2, 0.125, 0.125, anywhere between a 0.125 and a 0.13, right? Which gives that play of the M3 screw, right? It gives you that play, okay? And the reason why we want that play to be there is so that the bite of the screw is not inside of the hole, but there's a loose play, right? There'll be a loose play. Now there are other ways to do this as well. Like if you have some sort of metal shield that you like for the screws to sit inside of, so that the plastic doesn't build up friction on the screws. You can add to it. You know, if you have heat sets that you want to put inside of one side, you can build that in later as well. These are all things that you can do to kind of help you to get this to be how you want it to be. So now, based off of this, what we're going to do is we're going to take it and guess what number we're going to use to create our outer structure. You guessed it, 0.4. That's exactly the number that we're going to continue to use. We're going to do it over and over until it sinks in. We're going to get our 0.13 up here because that's going to be the top side holes, right? Now the top side holes are just going to be, they're going to be regular straight bars. You know, with these bars, you can get as creative as you want to get to. You can have them to be whatever shape you want them to be. As long as that these planes here are flat. Sometimes you can have a little bow to the top knuckle. It doesn't even matter, man. You can do so much with these swing arms. You just get creative however you like to get creative with them. After we get our center holes, we're going to go back in. Now, there's two ways to do this. You can draw you another circle, or you can go up there and create you a offset. Now me, you know, I'm gonna keep it 100. I'm gonna do it how I'm gonna like to do it. You know, I'm gonna go one step further though, because we would, in this case, we would have to chop down the 1 point or the 0.4, right? We'd have to cut that in half because we're dealing with circles, which would be a 0.2, but we're going to add a little extra meat to it. So we're going to add a 0.1 to it. So we're going to end up with a 0.3, right? I know I said a 0.4, but we're going to go 0.3 because that's half of what we're dealing with, because we want a little extra, you know. I like to get a little extra on these holes, so that we have a little sturdiness, a little thickness going on here. 0.3. Right? And all of these, like, you can, if you was trying to get this done faster, you can draw a center line, and all of these could be you know, copied and pasted, mirrored images, and instead of having to do all these holes by hand individually. But I don't care to do, it don't matter to me. We in here together, we doing this big time. We're gonna keep this thing moving and flowing, you feel me? So we got these here. This portion here will be extruded. These holes will be cut out. They'll be extruded for a purpose of being cut out. Also, this is going to, we're going to add some integrity to these too by attaching a line here and these areas here. And, or even maybe doing a fillet on these edges to give it the thickness that we want it to have. Okay. That's a lot of that goes into designing as far as these parts. Is that you pretty much could do whatever you want to do with them, it's just a matter of you designing these, how are you going to design them, right? So we can zoom in. These same holes are going to line up in reference to the actual swing arms that we're going to do. So we're going to use these multiple times. So we're going to design it all in one spot at the same time. We're going to design them all, right? So we're going to, first thing we're going to do is we're going to extrude these outer parts, right? Shift. Press these right here, right? We're going to extrude them. So we'll finish the drawing, extrude, right? And with this extrude, we'll just click on the opposite side of this wall here, and it's going to identify as a cut. We don't want to do a cut, so we'll change the operation from cut to join. We'll join them, and then they'll become solid pieces. But also, when we complete that, we have an area here that is still in a square form that we need to cut out. So we're gonna make that last sketch that we did visible again. We're gonna go back in here and select the center holes. We're gonna do that same thing that we just got through doing. Only difference is that it's going to cut out that hole rather than joining it. So we'll go back to the other side. We'll click on that side again, and it creates these holes, right? And sometimes you can, if you want to be on the safe side, you can extend the holes out further than the wall. What that allows you to do is cut the full length of these blocks. Sometimes the dimensions of your blocks are going to be off by so many points, right? And even if you cut directly, there'll still be like a thin layer or wall that's invisible until you get ready to transfer it over to your STL files or your 3MF files. And when that happens, you'll have like a layer that prints. It'll be a 1mm layer that will try to print that is invisible, and you'll see it in your print, and you'll be like, why does this keep on happening? And it'll be because of like a small area on the wall here that you failed to remove. All right, so now that we have this, right, we want to go back into that picture that we have, right? Going right back into that picture. What we gotta do? What we gotta do, chat? We gotta go back into that sketch, right? And we're gonna use the same objects to make our swing arms. And because we're gonna make these swing arms, we're gonna select them and draw straight bars straight across. that's going to give us that leverage that we need for these holes to go together on the swing arms. So we'll go to edit. All I did was I clicked down here in the, click on that right there, right click on it, and it'll give you options, and then you click edit. It brings you right back into that same drawing. Then I'll go up here, create a line from the edge. I can take it from this part here, draw it straight across, bow, right? And because I get one side together, now I have a snap on this side. If I try to draw this bottom side first, sometimes it won't do it. And then you're looking for that circle with the line through it to connect it on the bottom side. You can do the same thing to the top side. That circle just let you know that you're on the circle. It's an exact link to the circle. You can't miss it. All right, so while these top bars are not going to have anything connected to them for the spring, because the spring is just going to blow right past these. And in most cases, since we don't have a driving mechanism, we can actually have our servos to push straight down through the middle of these areas, right? Like we can cut a cavity for these to do their thing. We would have to have the right dimensions for the spring to actually fit down between these though. That's the only challenge of working with these front linkages, is having the space to insert one of these springs, whether it be a small one or a big one. You have to just figure out how it's going to play for you. If it doesn't fit down the middle, it's going to have to fit in the front or the back of these links, right? And also, you're going to have to figure out where you're going to place it according to where your servos are going to be sitting inside of the frame. So that's another thing to think about. But so what we're going to do for right now is we're going to extrude these out as how they are, just without the holes, with the holes in the middle, I mean, and these circles in that straight flat playing field, right? We're going to do them both at the same time. We're going to finish the sketch, right? We already have that. We're going to select these areas that we have here. We're going to go wholeheartedly. Bow, 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 right? We got two of them at the same time. We're going to hit the extrude button. We're going to come over here. We are going to, we're going to use a double-sided, right? Double-sided. Now for these, I do like to use inserts. So one side is going to have that 0.13 hole. The other side is going to have a divot that goes inside of the plastic. That's going to give us like a 0.15 hole for so I can use the brass inserts, right? Because I like to have one side where the screw goes through and then it actually screws into a nut on the other side. But I'm not going to use a nut though. I'm going to use the inserts. Inserts just look a lot cleaner. Also, we want on the other side, we want it to be to where the bolt is not, or the screw head is not sitting outside of the plastic. That's going to press inside the plastic as well. Looks for a way more cooler look, way more sleek. So we're going to do not symmetrical, but we're going to do two-sided because we want one side to extend out 0.2, or no, 0.3, I think. This is where you have to come back in here and get your screws. Now I have flat head screws that I like to use for this portion. See, flats inside of here. But usually that head, whatever your screw is that you're going to use, which we're going to use the M3s, is going to have a head depth thickness on it. you want to measure those out because those are going to help you get that clearance that you want to get later on when you're mounting. Let me get one of those screws out. And it's always cool to have you a screw, to have you a screw or two on hand, and also to have you some inserts on hand. You use the inserts or nuts. So, and your calipers. So the screw head is a 21. So because it's a 21, I always take it up because I want it to have a smooth uh, slide in portion to it. And then that width is a 0.12, right? I wanted to encase, sit a little flush, so I'll put a 0.25 on the left side after the meat that I want the swing arms to have. Now I want the swing arm to be like at a 0.22, a 0.25. We could do a 0.20. It doesn't. 0.25 would be a good number, I'm guessing. 0.25 is not bad. Mainly just what we're looking to do here. So a 0.25, right? So we said a 0.25 plus a 0.13. 0.25 plus a 0.13, right? That would be, I'm blank real quick, y'all. 0.13 plus a 0.25 would be 38.38, right? So that'd be 0.38 on that side for that swing arm. And then on this opposite side, we're gonna do flush, which would give us that 0.5. Then we have to add in that 38, which would make this a 88, right? It look almost the same on both sides, right? We do not want those to match, to get, we don't want all this to be cut or joined together. So what we're going to do is we're going to change this to join, right? And then we're going to make the knuckles invisible. That knuckle invisible and make that knuckle invisible. That's part of, we still haven't named that yet, but we're gonna do that, right? Yeah. So now we have these portions, right? So now that we have these portions, we go back. The reason why we have to go back is because now we have to create a space for that linkage to be, right? We can't just have uh, this here with no room for the inside portion to go, right? So we'll start out by picking, hmm, there's a bunch of ways to do this too. This is what I was talking about as far as having designs, because from the top portion, this area here would be hollowed out, right? This side would have some sort of knuckle bar at the bottom, not the top portion, but the bottom, um, where the top, how do I explain this? So this portion could be open, right? And still have like some connection to it on this back side. because it'll just be the spring would be passing through the top portion because of the servo mount. So that portion can be open all the way for the passing of the servo and the spring mount or whatever, which could be mounted on the outside. So you have a servo swing arm swing down through the middle, and push on the area where the spring is going to be. Having these springs and the width of them is going to play a major part into that center cavity area. Right now, the springs that I have is a 0.45. I'm not sure exactly what size springs Derek is going to have. So I have to leave wiggle room, which is probably going to put us at like a 0.5. A 0.5 or more. It's gonna have to be more than a 0.5, I think. We're not going to be able to. Here, let me see. Yeah, this the portion that this the part where things get kind of tricky because you want the space for this to happen. It's already at a 0.5, which is the width of this here, which should sit kind of nice. But if we're going to we're going to be making sure that this thing could fit, different types of springs, we're gonna have to space them out, right? We're gonna have to give them room to breathe. So that's where these offsets is gonna happen in the inside of this cutout area that we're gonna be forming right now. So we got that right there. That cutout portion is going to happen from this inside area here. Also, if we want to bring the placement of this outward, we could bring the placement of the inner side of the knuckles outward to give us more space for those swing arms as well. This top portion is probably going to go away and possibly going to split out to this surface here to be wedged from the outside rather than a bolt going straight through. We might just have two screws on the outside, leaving this center area open for that swing arm to do its thing. But I mean, that's all something that you think about during the this process. Let's see, we're at 2 hours. Let's see if we can go another hour, and then we'll call it one, and we'll come back tomorrow and do a little more. Okay. Shoot. What do I want to do? What do I want to do? I think what I'm gonna do is I'm gonna hollow out that center area, but I'm going to box the side of it, right? So this is what I mean by I'm a box. I'm gonna go back into the sketch, right? So I'm gonna get rid of these, right? We're gonna go back into that sketch area. We are going to edit it, and we're gonna clear that box. Remember how we made those boxes before, where we went from the center area, came down, and did our thing? Same difference here. It's 3 by 3, right? 3 coupled by 0.3. Put it right there, like that. Same difference for all of these. Like I was saying before, if we had a center line that we were drawing into, we could just, come in from the side angle and make that happen 0.3 on top of 0.3. Okay. The goal here is to never complicate anything. The simplest way is always the best way. And it helps your brain to hold on to the information. Helps you to be able to hold on to the information on the not just the information, but the measurements that you're dealing with. It's just to keep it simple. I mean, that's the best thing you can do for your brain, especially with all of these type of numbers and number crunching and all that stuff. When you complicate it, then it gets annoying later on when you're trying to remember what numbers you went with, and if there's an awkward number or unusual number or whatever, yeah, we undo that. I don't remember recall what I did there, but yeah, yeah. All right. So the area we want to carve out damn near is the square um from where that circle is. Okay. Now I didn't necessarily have to cut these off like how I did. I could have just left them as is, complete the picture, came in here, selected the box or whatever, made my cut. I could have did this the whole way, right? Select the whole box area. This is when your brain goes on autopilot. Sometimes you'll end up doing extra work when you don't have to. There's always an easier way to do something. The difference is the learning curve. Sometimes you just haven't learned that specific strategy yet, and that's all right, you know. But don't let it be like something that people will critique you about and it makes you feel a certain type of way. I say don't worry about it. Um, if it's logical and you're making it happen, you're doing what you need to do, um, I wouldn't worry about it. So from this point, we are at a negative 0.5, right? Because that would be the thickness of that piece that we had. Negative 0.5 puts us clear smack down the middle of what we see here. We are cutting those pieces out. So we'll go ahead and cut those, right? This gives us a view into what just happened. See, we have right here firsthand what happens when the cut is not precise or the picture is not precise to the actual surface that you're working on. Now see these tabs here? There's a tab right there that is too thin to be like its own body. It's too thin to be its own body, but it's there and it will print if you do not catch these and remove them. So what we do is extrude these and cut out against it, and that makes it disappear. Sometimes that happens. It don't happen all the time, but sometimes you will get these little stragglers that they pop out of nowhere, and you have to be able to take care of them before they become a part of the structure, whatever you got going on. And on these ones, I like to do simultaneously, symmetrical, so that it cuts both sides. You know, this gets rid of all of it in one swipe on both sides. You can do that for the other side too. The only thing you have to do is select just one side, and it will take care of both sides if you swipe symmetrical. Pull it up, in both directions. It chops it right down the middle, gets rid of all of it. Okay. Now we have this flat edge, right? This flat edge is going to be extruded inward, and we're going to have to create some sort of design so that this thing is either it can be all the way cut to where these are individual, but they still function together. The bottom portion is going to have to be together so that we can have some sort of stability on the locking of the spring, right? Because the spring is going to get sandwiched in between here. But I mean, it builds that sturdiness to have it together. If you don't have the spacing properly to be able to do it, then you can always just cut them down the middle and cut this whole center area out and just have two sides, and you can play them out that way. This top portion, I might end up doing that with. I may end up just chopping the center out of there. It's not a bad idea to think about. Just having two rods that would do that. You do push this one, push this one back. 0.6. Yeah, we can go 0.6. We can try 0.6 with this. We can also round these edges out later on. We can chamfer them. Or we can, put a fillet on there and build that meatiness back up. Let's say negative 0.7. We can shoot for that. It did it to us again. Get rid of that. And that's just something you gotta look forward to when designing sometimes. These things will kind of give you a hard time sometimes. But I mean, your mind just gotta think about how to make it work. You have to think about how it's gonna come together, how it's gonna work. Then you'll be all right. This could be rounded out, chamfered on top and bottom to give you more leeway on these rods when these get bending up and down. Or you can chamfer them to where they're flat, vertical 45-degree angle cuts. That works as well. That probably be the case for the top portion and the bottom portion on this side that's closest to the knuckle. If we bring the knuckle back, you can see that link falling into place, right? You see that link coming together nicely. The 45-degree angle would guarantee that this angle here, that corner, is not going to bind up on the wall of this knuckle. Okay, because what we want to do is we want to build up the structure on this knuckle so that that circle has more strength. We want those areas to have a lot more strength than just the circle attached to the square. So what we'll do is flare those out with the fillet, which you all will see in a little bit. And it'll make more sense to why we're doing what we're doing right here. Also, that this area here, there's going to be a hole inserted here to where whatever spring size that we need is going to, be able to fit down inside of there. The bolts will go through on the hole somewhere in here, and that will be how this spring goes through here and actuates this arm. And then comes the fancy part where we start designing the aesthetics of how we want it to look. If this was aluminum, then we would be trimming out parts, trimming out hollow areas like in the side of this area here to make it hollow to save weight distribution. You know, making these parts lighter. Uh, that's not necessary for this. We're 3D printing these, so uh, the structure is going to be a lot different. We're not going to focus a whole lot on it. What we want to build up is the strength of these parts. And when you're trying to build up the strength of the parts, um, sometimes you're going to have bulkier parts with the plastics. Bottom swing arm, right? Bottom swing arm, top. Swing arm, okay? And we just keep labeling these. You have to stay on board with the labeling. And this part right here is going to be like servo. No, it's not going to be servo. Uh, Front axle mount. So okay, y'all cannot see these words over here that's going on because I am labeling stuff, but it's not showing up for you all. But we are labeling these so they all have their own names and they're easy to find instead of just seeing like a shape or cylinder. All right, so now for the strengthening of this knuckle is our next portion. It's going to grab these edges here, top and bottom for this portion here to fill it. Let's fill it to be nice and that we can get it pulled out as far as we can get it. This adds the structure, back to this puts the strength back in this part. If we do not do this, then those sharp edges just become break off points. We don't want that at all. This comes in at a 0.9. We can possibly get it at a 0.1, or I mean just a 1, and that brings it out to a flat, smooth taper into that part right there. I think it's gonna be pretty cool when we get done with it. Then we're gonna take this inner edge as well. We're gonna do the same thing. It's probably gonna come in like around a 0.5 for this inner edge. Fill it. Usually, you want to add your fillets towards the end of your design. 0.5 here. It's a nice little bow out, to with the bowing out of this product though, or this part. This area here is going to have to be reflected on this bar as well, or it's going to just be a catch. It's going to be a block. So that's something that we'll have to cut this in work as well. That's a part of the aesthetics that you have to think about and figure out for you as well. 0.5 seems all right to me. Part, which that's what we need. We need the strength to be in this for the type of torque that these servos are going to have on these swing arms. And then these outer ones here, I'm holding shift to select those two areas. For that, see with that. It depends on what your style is with these. Um, Sometimes we can I don't like how these are touching. So what I'm gonna do is I'm gonna push it back before I do that. I'm gonna push these inward. So let's go full. We're gonna come over here. Now if I'm pushing things inward, you can either use this push. If you use this push, it'll push the outside of this wall as well in most cases. Um, but I don't want that bottom to have that double push. Just this portion here. We're gonna push this maybe a point. That's 0.5. I guess so. I guess this side of the wall is not it's not hindered by that push. I guess I would have had to select that area too. Oh, do that though. Do that. Like both sides here. Same that thickness, right? With the push. All right. So that's that what that would do. All right, we don't want to do that either. So we're just gonna grab one side and do them one at a time. Extrude. But that push changes the dynamics on the drawings when you push an object. It changes how it looks on the drawing as well. And if you just do the fillet, it'll cut the part, but it won't change it on the picture. It does nothing for it on top of the sketch. If you want to go back in and rework the sketch, it'll modify that sketch for you with the push. 0.5, then they want to push it out 0.10. We don't want 0.10. We want 0.05. 0.05. Sometimes this thing it be trying to challenge you, make sure you're on your P's and Q's, and that's what you just gotta be on your P's and Q's with it. See, now we have this here, we gotta extrude that and click on that level there. Because it did something crazy here. And this is all due to the way that I did these drawings, right? It always come back to get you. But then we come here, and then maybe that don't work. That's not gonna work. Somebody's telling me it's not gonna work that way. Nope. So we gotta extrude it out, right? Get our joint on, come here, cut it, so we can get rid of that line that was there. And it's crazy that we would have to keep on going through this. So we had multiple areas that had that cut off. And then when you're trying to get rid of these, you want to just remove them instead of deleting them because uh, it changes the parameters of the drawings or the sketches that you have already drawn up on these parts. It does something weird to them. It's like this right here. You zoom in, it's like a weird lip going on there. I can see it. It can't hide from me. They come to destroy your designs later on. You'll see them and you'll know them when you see them. They'll be destroying your design. So we're gonna push this one back 0.05 as well. And then also this whole time we've been designing, we haven't saved this thing not one time, but we are going to save it now. We'll call it 1960 Impala chassis, right? All right, back to what we was doing. Now that we have that done, it's working. It's working. I'm saving. Okay. And then we hit the home button so it can rewrite us. All right, we come in here and we're gonna get our shampoo. We're gonna get our fill it in like how we had it before. All right, grab that edge, hit our fillet, get in on a 0.1 is kind of where we want to get with it. Okay, and same thing for the bottom side too. Get in on a 0.1 fillet. That's out there. Okay, so that gives us the movement. Later on in another video, I'll probably show y'all how to position these parts to where they actually move like hinges, so you can test them, right? Because you're gonna need to test these sometimes to make sure that the linkages work according to how you got them mapped out, right? So this is a nice link that's put together here. The pivot points will be between these holes, and you will be able to move this part around and it will actuate for you, and you can check your dimensions. Now I've designed enough of these to know um, what I'm looking at is all right. Also the center area here, I'm probably gonna make it more open, just like I did this top one. I think that's the direction I'm gonna have to go. This portion here is gonna get cut back, right? Or what I will do, like I was saying before, is come at these from the outside. Leave this in center area open, cut this outward so it swings around and attaches to the outside. Leave a nice open gap here where it makes a U shape around here. That might be the direction I go with this. It'll be a new idea to play around with, and I think that it may actually work. We'll drop some, let's drop some, we'll drop some stuff and see where that goes. But the bottom portion here, we have to open. We're gonna have to open it all the way up to just like we did this one, I believe. So this is what I'll do. I'll grab that center wall and I'll extrude to that wall there. There's an awkward number. It's pushing out. Um, hmm. Maybe we'll cut it off at 5.5. 5.5 wouldn't leave enough room for the. Let's go. We could do the 0.7 would not be good though. Let me see. Yeah. It's a bottom anchor. Look like we lost some meat here. That's what it looks like. Hampered. All right, so let's cut that back. Let's see if we can push this. I think we lost some material here somehow. For some reason, it doesn't seem like we 0.05. It don't seem like we did the same amount of measurement there on that pushback, but it looks like we got it back. Bottom angle. See the amount of play that is happening here with these weird structures. You can see it from this angle here, but we don't see it up there. But rather than, so we'll do this. I have to come in and pull this, shoot it down like how we did before. Move those out of the way so we can grab that. Split the body. It splits into two different section pieces. Remove that piece there so it can be a solid, no lines, no gaps in between there. And that's what we have to consistently do. Especially whenever you see those parts doing stuff like that, you got to get rid of it. Like, it cannot be there. You have to get rid of it. Because it'll cause you problems in the long run, especially when you're trying to move your measurements around and the measurements right, it'll just be hold up. Chaperone again, 2.5 or 0.25. Looks like a good number to me to have this thing be sturdy, right? We'll have the thing down in the middle there. This right here, get that bottom swing arm back. We're gonna push for the same results here. We're gonna leave this bottom one open just like that. I'm not gonna fight against it. We're gonna regain our integrity back by shampooing, by doing the fillet on this one anyway. So we're not gonna even worry about trying to get that part perfect. We're just gonna keep on moving forward. Okay, 25, just like that. Now we got this thing kind of slowing on us. And we're gonna hit it for about 30 more minutes. Save that. Sometimes when you get too much going on inside of this platform and you have too many design features going on inside, the processor will start slowing down on you. But don't get discouraged. Just keep pushing. Keep doing what you're doing. Now we gotta go in and make that other knuckle part that we was talking about. We was making. Where was it? Run that some out. this part here, we're going to add a feature to where this thing goes around that other side there. It creates that illusion that we were talking about just then. And at this point, we're just thinking about the best way to go about it. The inside structure, we want it to be there. The thinking process of this. So we can extrude these on the opposite sides like how we were doing before. Crazy part is that we have to go back and look at how this is going to be seated inside of that wheel well. So let's go back to the body. Way up, way up. Drop the body down there. As we can see, we are nowhere near the height of, you know, what we're designing this thing to be like. So we possibly can go the extra mile and take it up higher. But this leaves a lot of space for us to mess around with the servos. So we got that in the front wheel, right? Which would be that space. Take move our wheel up. Let's move the rear one up too, because that's probably what's gonna happen to the rear wheel. We're gonna take it up 0.4. I believe that was what we did. Yeah, I think we did 0.4. Right? So this is just floor height, right? Floor height is a good space to start when you're creating the chassis. It gives you a center ground area for your swing arms. Now you want your swing arms, essentially you want your swing arms to be uh to have some sort of candid play when you add on the tires. This is why I created this wheelbase. Now I was expecting for the linkage of this to be a little more flat with the wheelbase or whatever. Uh, but this is fine still. This is only like a 0.2 gap in between. This would be like normal riding height. So when we add the tires on, we're gonna essentially be adding like another 0.3 to this maybe. Depending on the type of wheels we go with. We'll go with white walls. We're gonna be adding anywhere from a 0.3 to a 0.4 or 0.5 even. Um, but we need that to be able to clear inside of this wheel well, which I think we have it, you know. We can't necessarily see it right now. But yeah, we have the space for this to tuck in there really nicely. Okay. We have that structure, we have the space. So what we're looking to do from here is get our get our center spring to come through here at a reasonable height, to where it's not interfered by the frame. The frame should come over the top of this portion here where the swing arms are, and it should allow for a little bit of movement of the swing arms when we drop the frame in there. See how much play we have in here? This whole area is free to where we can have that. We can mount our servos probably off of this area right here, or even we can mount from the front portion of the chassis, right? But see how I left that bar in there, that portion of that bar? It gives us an idea of how much room we have to play with in the front. That's why we don't cut those off right away. Those could be an easy link area to where we can actually tie into it and not have to second guess where we're gonna line up if we decide to create off of this front area here. We don't have to try to line it up again. We could just mark up right off of the front side of this frame here. And then when we get where we're trying to get with the design, then we can cut this back. But we leave it there. We have it as a reference point for other parts that we might want to, continue with. But we have a good range here, and we don't have to really worry about that frame interfering with our linkage or anything. We are in good head space right now. And that's kind of what you want. That's exactly what you want. This amount of space that we are working with between here and here is going to give us that leverage. This wheel coming up to its full bottom out height is going to push this tire here closer to this frame here, but it shouldn't touch. It looked like it'll touch, but it shouldn't touch. You still will have a little play in between here for there to be ride height. Now, considering that we are not going to be using these wheels to turn, that's why we're able to bring this frame this close and to the wheel well. But essentially, you would pull this back, which we still could pull it back. The thing is that we don't have any brackets attached to it yet. We haven't designed any way to attach our axle to the frame yet. So that gives us the free play of designing this however we want to design it. Let's see how we're looking on time. All right, 15 more minutes of this, and then we'll cut it short, and we'll take it to the next level. So being that we want to leave this portion open, it's possible, and I'm thinking about this, it's possible to use like tri-links, which would have this frame, it would put us in a position to not necessarily no, I ain't gonna say that. I'm gonna just leave it how it is now. We are going to cut this part out though. This top portion here is gonna go away. I can see us having a hole here that goes through so we can so we can mount the bottom part of the shock to it. And then the top portion of this here, where this link happens here, we're going to have some outer structure activity going on with it. Meaning we might have to have a link coming from this top side here that's going to mount to the outside of these swing arms. Then we'll have the center area open. That might be the best route to do. I think that it will look really cool too if we can get something coming off of there that bends like something like a U shape, like that goes down here and kind of give it a really cool aesthetic. Um, do like some sort of tubing look. Well, I mean, but the ballpark is where we want to what we want to do with it. To give it the best structure that we can give it. I mean, we can also, like I said, we can also pull these inward, to hover right over these knuckle areas right here. And then we can just have those bars to come straight down. We can do that as well. Um, we can also create a 45-degree angle off of the frame. That would be another third way we could do this thing. But as far as that ride height, that is going to be crazy. Um, Towing it shouldn't be a problem working with tow. Another way to do it too is to design one of these inside of this system here so we can see exactly how it's going to sit and play out. But also, I have to get the information about what type of spring he's going to use because that's going to change the dimensions of these open spaces when we find out exactly what he's using. Plus, we're going to add in play for these here as well because these are sitting flush up against each other. We're going to have to create space. So the space is kind of something that I do last after I get the structure together. Then I start pushing those surfaces back, creating that width and that space that I need for it to move how it needs to move. But that's something that comes with later play, um, later on once we get all of the good, the solid parts together, the parts we want to be solid. Like the servo mountain part. Servo mountain will probably be like somewhere in here. Um, I like to work with this overhanging system where I create a overhang off of the brackets or the off of the side rails, and I tie into them, and those are actually the mounting points for the center servos and what you call it, and the swing arms and the axles. Um, so we will get more information about that, and then we'll move in from there. But I think we have a pretty good, solid stopping point for today. This is going to be kind of cool to design. Um, so again, shout out to Derek for um, dropping this 1960 on us, so we could actually, you know, map off of it, and I think it's gonna be a really cool project. You know, really cool project to put together. I'll let him once he get it where he needs to get it. Release the files and do whatever he wants to do with it. Well, that's what we got for today. We will be coming back tomorrow for another edition of this. To get this thing, get the front side together, get the rear side together. We'll go into a lot about how the switching mechanisms are gonna affect, how the wires run into the back of this thing. There's just a lot to think about when designing something like this. But the cool part is that we're in full control of exactly what we want to do, you know, what we want this car to have, what we don't want it to have. Um, we can do it all, you know, it's at the fingertips, you know. So thanks for tuning in. Thanks for supporting. Don't forget to subscribe, like, hit that bell button if you want to see more of this or be notified when I'm live again. Um, we're gonna keep this thing moving. Don't forget to share. All right. I love y'all. I'll see y'all in the next one.